Hello friends, my name is Arjun Sharma and this is my capstone project. My project name is Netflix Movies and TV Shows Clustering. Project type is unsupervised learning. My contribution is individual. Let's come to the project summary. This is my project summary. First of all, we prepare our data, that we upload our data first of all, then import the necessary libraries, importing datasets, finding missing data, encoding categorical data, data cleaning, and feature engineering. Then we do the exploratory data analysis. Then our project summary says that our primary goal is that we examine and categorize our data so that uh, the objective of to uncover the patterns and similarities within the platform's content and organize them into meaningful clusters. So we have the data set in Netflix in the form of movies and TV shows. These are the two categories, and from these two categories, we have many variables in this, which we see further, and we have to make the clusters or different clusters of the data sets. So technically, we could examine the new data and put it when we get the new data set, new rows. So we could put them forward in the proper clusters. So we make different clusters so that we could make the give the company contribute in the company for decision making by putting giving them the proper uh, uh, clusters in which we could put our data. This is our GitHub link. This is our problem statement. This data set comprises a collection of television shows and movies that were accessible on Netflix as the year as of the year 2019. The data was gathered from Flexible, a third-party search engine specifically designed for Netflix. In a noteworthy report released in 2018, Flexible revealed a fascinating trend: the quantity of TV shows available on Netflix and nearly tripled since 2010. Increasingly, during this same period, the number of movies offered by the streaming services had decreased over 2,000 titles. This integration shift in content distribution raises curiosity and motivation further exploration to uncover additional insights from the dataset. So these are our general guidelines. We have imported our dataset, imported our libraries, necessary libraries which we are going to use. This here we load our data. This is the first view: dataset head, dataset tell, then the rows and columns, counts of the rows and columns. There are 7,787 rows and 12 columns in our dataset. This is our dataset information. The data types, the null counts, null values, the duplicate values. We have zero duplicate values. These are the missing values, missing data. As we can see, director has 2,389 missing missing values in director column. In cast column, 718, country 507, date edit 10, rating 7. This is the visualization of the missing data, understanding our variables. These are the columns names. This is the data description. Here are the variable description in which we have the show ID. Every show ID has a unique ID, whether they are movies or TV show. Uh, type of whether it is a movie or a TV show. Title, a director, that name of the director, name of the director of the movie or the TV show, cast the actors in the show, country in which country the movie belongs to, date added date it was added to at which date it was added to Netflix, release year, actual release of the movie or show, rating, TV rating of the movie show, duration, the time duration or the number of season, listed in genre, its genre, description, that summary description of the movie or TV show. Check the unique values of each variable. These are the unique values of each variable. Data wrangling here, what we had here we had done the data wrangling. So this is the data wrangling we had done. We had make the date added column in the first of all in the date time uh, uh, form. Then we make new columns of day added at what is the day it was added. It was added on the Netflix in the year which year it was added to the Netflix and month. We have to make different columns from it. Here we say that we fill the in the cast there are missing values, so we had handled missing values by filling no cast in that empty feature. And in the country, the mode the more number of most number of countries we had added in it. But in this we are filling it. Data visualization, we come to the data visualization part. So in the data visualization, we first of all we see the content, the percentage of content. Most of the content we see the movies 69.1% movies and 30.9% TV shows are there. So the majority of content consumed on Netflix TV shows and representing 69.1% of the total, whereas movies contributes to smaller portion accounting 30.9. The data clearly shows a strong inclination towards TV shows, which accounts for 69.1% of the preference, while movies constitute a lower percentage of 30.9. This is my second chart. This shows how the content over added to the Netflix over the years. There we can see from 2016 to 2020, there is a rapid jump in the number of movies added to the Netflix, whereas a small uh, increase in numbers of the TV shows. But in the next, the third chart, monthly addition of movies and TV shows on Netflix. So this is the total addition of the monthly addition in which month in the month of October, November, December, and January, the number of edition on the Netflix content is higher. From the second month, from February, it is the lowest. The third chart, we can see the Netflix content over the year, differentiating it in the movies and TV shows. So in the first month, the TV shows and the similar kinds of trends are we can see. The TV shows are added mostly in the October, November, and December months, whereas the movies follows the almost the uniform trend. This plot for the normal distribution for the movies and TV shows. This is the distribution plot of the timing. It is the duration. So the most the duration of the movies and TV shows is almost near to the 100 minutes. It is, we can say, from the almost 80 to 120 minutes is the mean, and it is showing the normal kind of normal distribution of TV shows. The how what is the number of seasons? So most of the TV shows are of only one season, having the one season. Then two, there is a huge difference for the in between the first season and second season, and there's a gradual decrease as the number of season increase. The percentage of original and others in movies. So we can see there is original is 30.02 and the others are 69.98, almost equal to 70%. Certainly, what insights the use of the pie chart is appropriate for representing categorical data distribution, like the portion of original versus others is in this context. So, what is the insights from the chart? Among the movies accessible on Netflix, 30% are productions directly from Netflix, and 70% consist of the films released through various distribution channels before being incorporated into the Netflix library. So there are top 10 TV actors and top 10 movie actors. So as we can see, the Anupam Kher and Shah Rukh Khan are the top two actors acted in the number of movies the most, and the Takahiro Sakuri and Yuki Kaji. These are the top two actors acts in the TV shows. Number of TV shows they had done highest is for 12, followed by the Yuki Kaji and so on. This 22, Anupam Kher 41, Shah Rukh Khan 35, Om Puri 30, and so on. Then we can see the top 10 genre on Netflix. The genre uh, having the top 10. So documentaries are highest 14.4%. Then dramas and international movies is 13.8%, and stand-up comedy 13.9%, and so on. Then we can see the top 10 countries and the content they've provided. So the top 10 countries we have, first of all, we can see that it's United States of America. Most of the dramas are there, followed then comedies, and as we can see in India, there is highest number of international movies, then dramas. There is a distribution for the different countries, what type of content these countries like to watch, people of these countries prefer. This is the distribution of release year. This is the univariate and bivariant distribution. So this is the total number of content distribution of the year, and this is the bivariant. There is a movies and TV shows. So as we can see, as the number time is passing, the content is rapidly increasing, both in the movies and TV shows. But as we can see, the movies are increasing um, at a greater rate. Top 10 ratings for different age groups and audience, and rating based on the movies and TV shows. So these are again a univariant and bivariant distribution for the top 10, the ratings, as we can see, for the movies and TV shows. Top 15 directors with the highest number of movies and TV shows. So these are the top 15 directors with the highest number of movies and TV shows. So Raul Campos, Chance Sutter having the highest 18 number of movies and TV shows. Then top 10 genre with counts. So documentaries are highest 334. Then followed stand-up comedy followed it. Then dramas and international movies. Correlation heat map. So here is our correlation heat map according to the uh, in United States of America, the 47% of the viewerships comes from the adults and teens and 24%. In India, the highest numbers are teens, followed the adults. So that is an interesting survey. The teenagers watches the most on the Netflix, use the Netflix the most. Whether in other countries like US, UK, Canada, the adults are most on the Netflix. This is the hypothesis testing we had done. So in the hypothesis testing, first of all, these are the ratings we had uh, dis- discriminate according to the four groups like teens, kids, older kids, and the adults. So what after that we had done the uh, categorical function we had used in target ages column. Then duration we had uh, we we done some feature engineering and make the duration in the numeric form. Then this is our group data set. So what we just come out with the mean for the movies rated for kids in duration and for a mean for movies rated for older kids duration and standard deviation for movies for kids and standard deviation for movies rated for older kids duration. So here we calculated it all, and for the hypothesis testing we had calculated the t value. So this is the here we calculated this t value for our hypothesis. The hypothesis is that whether the our null hypothesis is that the movies intended for children and older kids have a minimum duration of 2 hours. So we had calculated that the minimum at least the TV shows and movies are of the minimum time is it's 2 hours. This is our null hypothesis. And alternate hypothesis is movies intended for children and older kids do not have a minimum duration of 2 hours. So this is our alternate hypothesis. So for that we had calculated the t value. The t value is minus 11.51. So for the this we calculated the t stats for the 25 for 0.025 and degree of freedom we had calculated. So it is in the range minus 1.962 to 1.962. So clearly t value is not in this between. So our null hypothesis has failed. It means that the uh, alternate hypothesis pass means movies intended for children and older kids do not have a minimum duration of 2 hours. We had done another hypothesis also, the duration which is more than 90 minutes for movies. This is our null hypothesis. The duration which is more than 90 minutes are not movies. The whatever the show, it is if it is more than 90 minutes, then it is not a movie. So this is our null hypothesis. So again, we had done this same process, and we do find that this time our t value is 249, and our the range which is come out to be the minus 1.960 to 1.960. So this clearly it is not in our range, means our null hypothesis is not with could not withstand. So the duration which is our alternate hypothesis part, which is the duration which is more than 90 minutes, are movies. So it could be a movie. So we had used T distribution here, and now we come to the feature engineering. So we had done the feature engineering in which we make a cluster column. This is our cluster column which is made up of director, the cast name, the country name, the listed in the genre, and the description. So what we have done in this is we had done textual data pre-processing. This is the function data transform text, in which we transform our this is the function in which we by using it we transform our data. So we transform our data by in which we had clean our data by make it all the values, the lower values. We remove the stop words in it from it. We remove the URLs and so on. So after the text, we had done the text vectorization. So and after the text vectorization, the shape of our set has comes to the 7,787 number of rows and 20,000 number of columns, in which the all the words which we created comes in. So after that, what we had done is the dimensionality reduction. We do the dimensionality reduction by using PCA, principal component analysis. So in by using the PCA, we found that the cumulative explained variance versus the number of components. So we got to know that the number of components, number of variables we need is around between 5,000 to 6,000. So we transform our data. Now the our dimensional got reduced, and now our data is of 7,787 number of rows and only 5,653 number of columns are there. And we implement our model by using the Silvercut score. We got 5 as the where our elbow is formed for our data set, and this Silvercut score we make around, this is our function for making the number of clusters. So we by using this function we made around 15 numbers of uh, different clusters, ranges of clusters. So this is two clusters, and that we had made three clusters. So this is the visualization for the clusters which we had made, different number of clusters ranges. So this is our, so this is our uh, uh, yes, this is our the cluster number of different clusters. There are 15 clusters we had made. So this is it. Here is the we had made the word count functions. So for the different clusters, we got different words which are dominating. Mostly come this is, here comes the TV shows. TV shows, show TV, movies. These are the different words column. So what are the words which we got from this? So category is mostly the movies and TV show titles, Broadway, uh, Randstad, Christmas, Friendship, United Kingdom, TVMA, PGTA. The genre is dramas, international musical dramas, musical documentaries, and in description documentary music one. But so these are the different variables which comes out, which are which comes in the different variables. And we do the recommender systems. This recommender systems recommends us the recommender system recommends us the uh, which type which what are the different clusters which we could create in our for our data sets. So this is now the conclusion. So notably, a significant portion of Netflix content comprises movies, but the platform has increasingly shifted its focus toward TV shows in recent years. So in the recent years, the TV shows are in the more focus. So the majority of these shows are typically released either at the first start or end of the year. So the most of the TV shows are released in the end of the year or at the start of the year. The US and India are among the leading countries responsible for producing content on Netflix. Furthermore, six out of the top 10 actors with the highest number of appearances are from India. TVMA content rating stands out as the most prevalent on Netflix, indicating a preference for mature content among TV viewers. Researchers determined that setting k equals to 15 was the optimal choice for clustering the data, allowing the content to be grouped into 10 distinct clusters. Utilizing this data and a content-based recommender system was developed using cosine similarities. This system offers personalized recommendation for both movies and TV shows. So, thank you.